All right, so we're back. A couple more examples like this, and then when we get into the complex fractions, that's when it literally gets complex. 6x over x squared minus 4. So as soon as you see a minus, check to see if it's a difference of two squares. X squared minus 4 obviously is. Plus 3 over 2 minus x. Okay, so this should put your radar up, right? You see the difference of two squares. You know that's x plus 2 times x minus 2. Very close to this, but not quite. But if we factor out a negative, then we're good to go. Okay? So you want to do that first. You want to factor this. 6x over x plus 2, x minus 2. Plus 3 over, because you want 2 minus x to become x minus 2, just factor out a negative. And you get negative 2 plus x, which is the same as x minus 2. Okay, so now we're really close to a common denominator. We just have to multiply this one by x plus 2 over x plus 2. So we'll still have 6x over x plus 2 times x minus 2 plus 3 times, we already have x minus 2, so x plus 2 over a negative, you can rewrite this as x minus 2 times x plus 2. Okay, which will change the whole thing into a subtraction problem or a negative. All right, so then we'll have 6x over x plus 2, x minus 2. And then we can just say it's the same denominator if we make this minus on the top. So minus, I'm going to go ahead and distribute now, minus 3x minus 6. Okay. You can simplify that. I'm just trying to think if they factor first. No, they don't. Okay. All right, we're good. So we can make that 3x minus 6 over x plus 2 times x minus 2. Factor the top. You can factor a 3 out of there. And you'll get x minus 2 over x plus 2 times x minus 2. And then you can cross out the x minus 2. And you'll be left with 3 over x plus 2. Okay? If you watch this before you take the quiz, on the quiz tonight, they're going to ask you about domains. So here you can't, x cannot equal negative 2. Okay. All right, and we're good. A couple more like this. X over x squared minus 5x plus 6. So already should be thinking factoring. Minus 1 over x squared minus x minus 2. Okay. So I'm going to factor this to be x minus 3, x minus 2. So then hopefully one of the factors here is the same. Obviously I can have an x minus 2 and an x plus 1 would work. Okay, so now they both have an x minus 2. I'm going to have to multiply this one by x minus 3 over x minus 3 and multiply this one by x plus 1 over x plus 1. And I'm multiplying this one by x minus 3. And this is why I say just leave the denominator as it is, because otherwise you're going to have a big mess down there. Okay, so on the top we have x squared. You know what? Do they simplify that? Let me check. They do. Okay. X squared plus x minus x. I was just thinking ahead if they were going to factor. Plus 3. Negative times negative. Over this whole enchilada. X minus 3 times x minus 2. X plus 1. Okay. So x minus x is going to cancel out, and you'll be left with x squared plus 3, which is prime. So we'll just stay like that. By the way, I think they've sent you the idea surveys, so please fill those out. Okay. X squared plus 3 over x minus 3 times x minus 2 times x plus 1. All right, one more like this, and then we'll go on to complex numbers. 4x over x squared minus 16. So again, radar goes up. You're thinking difference of two squares, hopefully. Plus x over x plus 4. You got a factor of it, you're good to go. Minus 2 over x. And that's when it's going to become a little bit tricky, okay? Because that doesn't have a factor. So we're going to have to multiply that by x plus 4 times x minus 4. Okay, so let's factor first. We'll get 4x over difference of two squares, x plus 4, x minus 4. The other two will stay the same because you can't factor them any further. But it will just show us that we need to multiply this one by x minus 4 and x. This one we have to multiply by x plus 4 and x minus 4. And this one we just have to multiply by x. Okay. So 4x times x, and this whole thing, x plus 4 times x minus 4 times x plus x times x times x minus 4 over x plus 4, x minus 4, and x minus 2 over x plus 4, times x plus 4, x minus 4. And you'll be left with x on the bottom times x plus 4, x minus 4. Okay, so now we have a common denominator. I would simplify the top first of each fraction and then combine them. So we'll get 4x squared plus x squared. Ooh, that one's pretty. Just trying to see it. So they did x squared times x minus 4, right? They took an extra step here. X squared times x minus 4. Did they simplify that one? They did. So they did it like this. They did minus 2. And x plus 4 times x minus 4 is the same as x squared minus 16. Okay, so this one is pretty. They simplified further. So this is still x plus 4, x minus 4, and x. All right, the top is going to become 4x squared plus x cubed minus 4x squared, which is good. That term will drop out. Minus 2x squared plus 32. And that's all over x plus 4, x minus 4 times x. Okay, if we simplify the top, like I said, 4x squared minus 4x cubed drops out, or 4x squared, sorry. So we'll be left with x cubed minus 2x squared plus 2 times 36 is 32. So plus 32. And can we factor that? We can't. So we're done at that part once I put the denominator. X plus 4. X minus 4 and X. All right, so that one was a little bit of work, huh? Like I said, next we'll move on to complex fractions.